Nobody has pinged me. I think we should start.
Okay, cool. Let me share my screen. Okay. So what we are doing in this cohort is we are building a. So the name of the cohort is building a distributed cache. We'll move there. But right now what we are doing is we are building a StylusDB SQL, a SQL version of the same database. And we are going to deep dive into that only for now. Yeah, I am Chakshu for people who are new. I'm a staff engineer at Samadra, which is an impact-driven governance consulting firm. I've been in this industry for over 8 years. Yeah, you can reach out to me either on GitHub, LinkedIn, or Gmail. I'll put this on slideshow now. Cool. There are some pre-reads or references that you can go through. Yash will share the deck later after this call, so we can just go through all of these as well. I'll just recap what we have done. Some of the cohorts mindset. It's a action-focused, action bias kind of a thing. It helps as a facilitator. I don't want to spoon feed anyone. That's not the objective. I want to figure out how to get curious people to do all of the stuff on their own. That's the entire objective of this community as well as this cohort itself. It's a detail-oriented approach. Feel free to ask as many questions around details. If I'll not know, I'll get back later. But yeah, that's the entire objective. So be as objective and detail-oriented as needed. Be action-biased, proactive. It's a coding-based cohort. It's not a tutorial hell. You are expected to do the tutorials that are available here and do it on your own. It's an engineering-based mindset. Just go through all of these Akin's laws of spacecraft design. If you haven't already, this is something that you should be focusing on as a growth mindset as well. Right. I'll not go into the week by week plan. We have already moved ahead from that. Reference books and resources are here. These are some of the best books out there. Alex Petrov has done a very good job around database internals. Right. Moving on, we started with very basic assignments. We then moved on to steps 1 to 13 from StylusDB SQL, which are available right now as well. So you can just go through and get the basics of your own DB running. Steps 14 to 20 are a bit challenging as this involves integration of the database with other services. It also involves creating a server for your database and creating a CLI for your database as well. So these are like some of the advanced steps. That's why we have segregated them as 14 to 20. Right, then what we did was we did a Prisma integration in the last session, which was around a month back, month or maybe even more. Right, so that is also something that you can check out. The next thing is we'll start today with how we can efficiently count something in a database. So essentially, this is a huge problem where probably you may want to figure out how many users are visiting your website, how many different users are using particular features of the app. So probably you have like a large columnar database having all of the information, and then you're trying to figure out how to do this fast enough or do this immediately at the runtime. So that's the kind of problem statement that we'll be solving today. Right. Moving on to how we do this traditionally. Generally, what happens is you try and create an array. You save all of the data in an array and try to figure out what are the unique set of elements. But yeah, open to thoughts here. I'll try to pause here and get your opinion on how you would want to do this traditionally. Are there any faster algorithms than just looping over the entire data and checking if it is distinct or not? Yes, anything comes to mind?
Maybe we use hashing.
Okay, yes, we can use hashing. So you want to hash everything out there?
Maybe something like the FP algorithm that we use in data streaming to count distinct elements. basically it's based on approximation, but I think that is something that falls in line with this, no?
Got it. Got it. Anyone else? Like, what are the traditional approaches? Like non-probabilistic. How do you get the exact count of a large big data set? Utkarsh, do you want to chime in?
Sir, I was also thinking of hashing.
Okay. Okay. So let's move on to the common ways of doing it. Let's move them out of the way. So first would be just create two loops, loop over them again and again, and then figure out. That's the most basic solution that you'll do in class 10th kind of a thing. Then what you can do is you can sort that data out as well. So what we are trying to do here is figure out number of unique users coming to the website, and the only thing unique about a user is the IP address that they're using. Okay. So what we can do is we can sort them out, and then we can figure out if the new user that is coming in is unique or not by just checking them in the sorted array that you have. Okay, so that will take up O n log n to figure out, and then the amount of space that you would require is O n. Okay. Similarly, what you guys said, hashing is probably so what you can do is you can have like a space of ON, but what will happen is 1 GB of IP addresses 1 billion IP addresses will take around 1 GB of data, and that would just be in memory. Okay, so if you have more number of data points, probably this may not scale because you may not have 1 GB of memory for every person querying out there. Okay, so yeah, we may want to do better in terms of just hashing. Is everyone aligned here? So for small data, this absolutely works. This works fine, but for big data, this may not work out. Cool. आगे बढ़ते हैं. So what we want to do is we want to count approximately. And by approximately, I mean with a 5% plus minus 5% accuracy. And with some of the best algorithms, it can reach up to around plus minus 2% of accuracy. But yeah, that's where we want to reach, because a lot of business use cases don't actually want me to give the right numbers. The business team may just want numbers close enough to take a call rather than doing it accurately. Okay, so accurate numbers may not be required even. And what you can do is you can just go through. So these are just two blogs by an Oracle engineer, a product manager essentially. You can just go through all of them to figure out how, like, where approximate data is more utilized by a PM. Okay, so this is not just an engineering problem. A PM requires this to be done for a large variety of data sets, and may not want the accurate thing. May only want an approximate calculation out there. Okay, right. Moving forward. So what happens is when we're trying to, so let's say, I'm just suggesting here. Okay, so let's say if there is an algorithm that allows for O1 space. Okay, and O1 maybe it's negligible. There is an error rate of 2%, and the time it takes to insert a new data is O1 as well. Okay, and if you're doing it at runtime, it's everything is O1. Okay, so this is O1, this is O1, and if you have streaming data, the error rate is going to be around 2%. That's how it will be. So do you think this is good enough? I believe I cannot store a trillion size data set in the memory anyway, because it will take me around 1000 GBs of memory. I would rather have this kind of solution, but yeah, open to thoughts, and we can discuss this further as well. Okay, cool. Moving forward, yeah. So what we are going to do now is we are going to figure out how probabilistic counting works. Okay. So what happens is we try to figure out a hash and represent that in a binary string. So let's say hash of Bob is 010011. Okay, I'm just taking arbitrary values, but this is how any kind of hashing algorithm will work. It will output some binary stream for you, and it will have the same set of sorry, my bad. It will have the same set of digits. So this has like 6 bytes representation of Bob itself. Okay, when I do a hash again, it's deterministic. So no matter how many times I do hashing, this hash should be like a deterministic thing. Okay, so it's random and it's deterministic. Okay, these are two essential things for a hash for a probabilistic counting, because if this will give out something else, it probably will lead to something something wrong of accounting. Okay. Similarly, hash of Alice would be something like this. Hash of chakshu might be something like this. Okay. Right. So what we want to figure out based on just these binaries, how would I come up with a solution of counting? Any ideas here? I would want to stop here and try to figure out if someone can come up with just this, how can we calculate the count of numbers. So let's say there are only three strings, and I want to figure out the number 3 out of this itself. I have the binary 6. I can just pause. You guys can think, and then you can get back.
Maybe count the number of ones.
Count the number of ones in a single year. Yeah.
Maybe in a single and take the max of it or the average of all of this. I mean, I'm just, for example, all of these strings, all of them have only 3 ones. I mean, this might be a coincidence here that the number of unique strings is 3. We are getting 3 ones. But since you have a binary string, and so I think counting number of zeros or maybe the number of ones would be the way to go.
This is getting closer. Anyone else?
Number of continuous ones.
That's actually a very good idea. That's something that we are going to get into as well. So what we are going to do is we are going to start from the left, okay, and we are going to figure out when is the first one coming up. Okay, since everything is starting from 0, we'll figure out when is the first one coming up. So if I just count, the first one comes after 1. Okay, for Alice it's after 2, and for Chakshu it's after 2. So what we can do is we can assume that there can be at most 8. So if we only see the first 3 bits, we can see that there can be at most 8 combinations that are possible. Okay. So if I just try to predict this, I can say that it has to be 2 to the power 3 because I can see this happening here. Okay. Moving on to the next one, I'll just give a much more elaborate example of this. Let's go ahead and see this. Okay. So as you can see, what I've done is I have fruits and their binary strings. Okay. And I'm trying to figure out when is the first one coming from the right. Okay. So for the first one, it's the first index, first value itself. For the second one, it's at 2, and then it continues. Okay. So it's at 1, 2, 1, 2. So 1, 2 means that I'm at max at 2. So yahan tak agar main dekhun, so all I have is 4 different fruits. Okay. Make sense? Actually, there are 3 only, but what I can see is agar mere se 2 bytes dekhe jaएं, so it can either be 0 or 1 on the first 2 bytes, and I can see that there are only 2 types of 2 switches here. So I can have 4 yahan tak agar main dekhun to. If I add even 1 more yahan tak, banana tak, then also I can see that there are only 2 different types. So this probabilistic approach is working well enough for me right now. Okay, yahan tak dekha, so out of 5 fruits, I can see that 2 to the power 2 is still 4, so I'm doing well. Now this just breaks the entire thing. This just messes up the entire thing because now 2 to the power 5 is 32, and my entire logic breaks now. Okay, and this continues to happen in this way. Do you guys think we can do much better than this? Just doing this kind of a thing? Of course, we have a solution to इससे better तो कर ही सकते हैं, but I'm just thinking कैसे better कर सकते हैं. But yeah, let's get into the maths of it first, and then we'll figure out. I'll show some numbers and show some strings so that everything um, is has some kind of math basis now. Okay, so what I want to do is I want to say that the estimate of maximum counts is 2 to the power p max. For me, p max now is 5. Okay, so 2 to the power 5 is 32. So I can say that for 7 fruits, my estimate is 32. Okay, and what we'll do is over this period of time, we'll try to ensure that we get to the right number. Okay, and this we'll use the same exercise and try to get as much closer to 7 as possible. But yeah, this is what we have right now. Okay, and this is like a simple pseudo code that you can just go ahead and do to actually get 32 out of this as well. So all we are doing is we are trying to figure out number of trailing zeros in H, and then just adding a 1 to it. Okay, so this has 0 trailing ones, so it gets counted as 1, and so on. So okay, and at the very end of it, what I'm doing is I'm doing a 2 to the power p max, and m is an important part. M is the maximum cardinality. So my set is of 7. But the maximum cardinality that I'm getting is 2 to the power 5, which is 32. Is everyone clear on this?
Yes, Session.
So with this methodology, what we can do is we can just figure out maximum 2 to the power 5, 32. Maximum set itna hi ho sakta hai, and then that's all that we can do. Let's try to refine this a bit further. And before that, let's do some kind of a math more as well. So now what we have is p max is equal to maximum of, so what p max defines is that we can have a maximum 2 to the power p max unique IPs, which is our cardinality set. कि इतना maximum अगर मेरे पास 1 billion IPs होंगे, तो how much, what's the kind of number that I need to store to actually make this work? Can anyone guess for a billion? You can calculate using this itself. 1 billion के लिए कितना बड़ा number चाहिए होगा? What would be the p max for a billion m? Any guesses? करो जल्दी calculate करो.
$30. 30, 10 to the power 9, right? 2 to the power 10 is approximately, sorry.
हाँ, सही है. Don't worry about it. 30 is the right number. Okay, so all I have to do is I have to represent number 30 to actually figure out a count for 1 billion IPs. That's all that I require. Okay, so अगर हम पिछले वाले algorithm में जाएं, तो all I require is this is my space. Okay, p max is my space that I need to store to actually get the maximum cardinality का answer. Are you getting my point? इसमें? So p max एक number 32 number save करना is the only thing that I require. इसमें और कुछ भी नहीं है. Are you guys seeing any other space utilization that I'm doing right now in this algorithm? Probably p है और p max है, 2 हैं. So I think 2 of whatever that may be. Yeah. But log of m is what I have. Okay, log of m base 2 is what I require essentially. Is everyone aligned with this?
Yes.
पहले probability calculate, पहले जब probability नहीं थी, जब actual count था, तो 1 trillion के लिए we would have used 1000 GB of memory. Right now we are using just a single number. Okay, which is a 5-bit number, right? And thus for every MM entries, we only need वही मैं repeat कर रहा हूँ. So the amount of information that we are storing is Pmax, and the amount of bits required to store Pmax is वो anyway bits log में ही होता है, तो it becomes like log P. So what we are getting at is log of M is the number of bits that we require essentially to store the cardinality of a large set which is of the size M. तो 1 trillion के लिए it would come out to be log it would come out to be 5 bits. Okay. Right. Moving forward, let's see how we can improve this further. So right now, what we are seeing is we are seeing two problems here. One is that it can only estimate in powers of 2, which are huge for huge numbers. So yeah, so it will say 65,000 hai number count, या फिर 131 hai. Okay. It has nothing in between. So either it's 16 or 17 or whatever that may be, but it's still these two large numbers which are at a distance of 2 to the power 1 between them. It also depends on the luck. अगर hash change हो गया तो सब कुछ change हो जाएगा. Okay, so if hash or chakshu comes out to be this, then I have a cardinality of 2 to the power 5, जबकि मेरे पास set 1 का ही है. Okay, so my entire set is of size 1, but what I'm getting is 2 to the power 5. Okay, so how do we try to reduce this? We'll get into a little, but any guesses on how we can reduce this? एक बार मैं पीछे वाले diagram पे आ जाता हूँ. Just try to figure out how we can reduce this even further.
Ignore 5.
Ignore 5. Ignore 5. Yeah, that's actually one of the solutions as well. So you can ignore 5 and then you can get to a very good number, which is probably 2 to the power 3. 8 के आसपास आ जाएगा, right? That is actually a very good suggestion. This is something that happens as part of the original algorithm as well. But yeah, और क्या कर सकते हैं? Ignore 5 के अलावा. अगर 5 को इग्नोर नहीं करना होता तो what would we have done?
Maybe take some other measure of central tendency. Median निकाल लो.
That's a very good suggestion. Median is also a very मतलब some alternatives में median use होता है, but I'm looking for one. You're very close. There is one more word that I'm looking for.
I'm looking to get mod of the data or the average of data.
Average is the right term. So we are looking for a mean. So what we'll do is we'll figure out कि ये दोनों problems कैसे solve हो सकती हैं. I can take a mean. I can divide this problem statement to multiple parts, and I can take mean of all of those individual parts to actually figure out something. Okay, and let's see how we can solve using both of these issues. Okay, so what we want to do is we want to do an average over a large sample size, and how do we figure out a large sample size? The easiest is keep first 2 bits उठा लो and उसके basis पे bucketing कर लो. That's pretty straightforward. So what I'm doing is अब मैंने क्या किया, मैंने ये बिट पहले 2 बिट्स उठाए और उनके बेसिस पे बकेट बना लिया. तो जहां पे भी 0 0 है, ओके, यहाँ 0 0 है, यहाँ 0 0 है, and यहाँ 0 0 है. So what I'm doing is I'm bucketing just 4 of these here, okay, and then I'm bucketing 4 of these here, similarly, and so on and so forth. I can take the first 3 bits as well. अगर मेरा data set और बड़ा है, I want to create 8 buckets, or I want to create 16 buckets or 32 buckets. All of these are valid answers for it. You can even create 1,000 buckets. Okay, if you have a very large data set, probably 1,000 buckets is the right way to go about this. Okay, and let's see how this can start improving some of the probabilistic counting that we are doing. Okay, तो मैंने अब 4 बकेट बना दिए. इसका 2 आ रहा है, इसका 2 आ रहा है, इसका 5 आ रहा है, इसका 1 आ रहा है. If I average all of these, so what comes out to be 5, 9, 10, 2.5. Okay, which is much better than 5. Okay. And let's see how this pans out in maths as well. वही पुराने वाले equations we'll try to get to. So now what we have is average is 2.5. Okay, for every bucket 2 to the power 2.5 is 5.66. and 4 times the bucket is 22. Okay. Now, it's still giving a higher estimate for everything. Given that it's giving a higher estimate for everything, there is a correction factor that gets added. There's a normalization factor that gets added. So it's still far bigger than 7. But what we are doing is 32 se 22 aa gaye. Okay. So that's still improvement. 2 to the power 5 se 22 aa gaye. By just averaging this out. So moving forward, what we'll do is we'll add a normalization factor. So Google ne kya kiya? Google ne bola ki let's do this over 1,000 sample data sets and see what should be the normalization factor, so that ye bias nahi aaye. This should come something very close to what the actual numbers are. So they did this analysis and they came up with some math and figured out what should be the normalization factor. I'll come to the normalization factor in this one. So they said that the normalization factor should be 0.39. Okay. So let's just see 0.39 करके क्या फायदा हो रहा है. I'm just multiplying a normalization factor to E bucket and seeing that it comes out to be around 6.6 now, which is still much better than what was there earlier. And given that we are only storing this much amount of information, it's called a log-log algorithm. That's the only reason why this is called log-log algorithm. It's still not HyperLogLog, and we'll see how we can reach there. But what I can see is this is the culprit. This guy is not very good at reducing the entire thing. What can we do better at this level? Any guesses? The average is good. पहले से अच्छा हो गया, but what can we do better now? Bucketing कर लिया and averages निकाल लिए, but there is one more thing. Any guesses? And I'll just give you a hint. इसी mean का type change करना है. That's all that we have to do. This average का type needs to be changed. So we can do some other type of a mean. अगर guesses नहीं है तो I can move forward. But yeah, this is how it is. So rather than just doing average, Google ने बोला है कि harmonic mean works better for this case. तो हम लोग हार्मोनिक मीन ले लेंगे. तो 4/1/2, 1/2, 1/5, 1/5. It also reduces this to 1.81 now. So for me, the bucket size now is 2.181. So ये 3.5 आ गया. Estimation per bucket is 3.5. So उसका 4 times is still 14. And there is a normalization constant which has also changed from the previous one, क्योंकि वो average के लिए अलग normalization constant था. Harmonic mean के लिए अलग normalization constant है, which is 0.541. And this is what comes out to be 7.57 आ जाता है. इसका multiplication करके 4 into 3.5 into 0.541, which is very close to what we actually started with, which is still 0.57. So 10% का error तो है ही. That still hasn't gone. 8% का error है. But what we see is that over a very large data set, this reduces to around 2%. And if you create a very good hash function, ये hash function बहुत ही अच्छा होना चाहिए to actually, and there are specific hashes, murmur hash करके एक hash है, which is generally utilized to actually convert strings, any string to this one. Okay. Now, that string could be an IP, that string could be a combination of 2 fields, that string could be a combination of 15 fields. That all of that doesn't matter. The algorithm is agnostic of all of this. All it cares about is आप अपना string binary में ऐसे दिखाओ and just count the number of trailing zeros or when is the first one coming up. That all that you have to do is you have to just figure out that only, and that's it. And this is your HyperLogLog algorithm. It's less than 20 lines of code, and you can predict something at a 98% accuracy out there. Right. Cool. I also want you to go ahead and read the actual paper. It's pretty interesting. इसमें normalization factor का implementation. So normalization factor का number कैसे आया वो भी they have shown. You should go ahead and actually read this entire paper. The other thing that you can do is you can actually go ahead and see iska ek aur implementation improvement, which is HyperLogLog. They have added a third log. And what I'm doing is I'm looking for contributors to convert the only C++ library out there, which makes it a bit more challenging to use it anywhere else. Although sare databases is C++ mein hote hain, so it doesn't matter. But since our database is in JavaScript, we're probably looking for contributors out there who can convert HLL ka implementation into JavaScript. I've created a dummy repo which has the basic implementation of HyperLogLog. You can go ahead and start contributing here if you fancy this. This is a very simple implementation. There's less than 100 lines of code for actual production HyperLogLog. And I'll also show you यहाँ पे ये ठीक है. I think उतना deep में नहीं जाते अभी. But हाँ, this is what it is right now. You can also take a look at Postgres का HyperLogLog extension कैसे बनाएं. This is being done by Cytus. Cytus is a data company that builds Postgres extensions. So might as well go ahead and see this implementation too. There is a Redis implementation as well. You can go ahead and see a C file, a single C file, and this although Redis है तो इन्होंने वही same चीज 1600 lines में की है, but हाँ, this is exactly the HyperLogLog implementation that is out there. There are implementations in Presto. You can do the same thing through bitmaps as well. So bitmaps is just a different hash function. So that doesn't change anything. And a lot of databases are doing indexes using bitmaps. Actually, this should be part of the college curriculum as well. I think this paper is very good to understand how indexing is done in databases. You find out a bitmap big enough कि जिसका hash कभी कोई collide नहीं करेगा, and that's all that you have to do. Right. Cool. So please reach out to me. I'm getting deep into all of this stuff. So other if you want to contribute, more than happy to improve the JavaScript ecosystem out there, which has practically zero implementation, zero production ready implementations out there for HyperLogLog. Because database bante nahi hai and there is no need for this library. But yeah, since we are building our own database, so might as well do it. Right. So what we have done is we have actually added efficient counting in StylusDB SQL. So so now we have support for distinct column array inside the count as well. So you can do select count star, which is like basic. Select count star currently doesn't default to approximate count abhi ke liye, but moving forward that would be the default. Whenever I add that memory ka layer, it will start becoming like the default for count. So you have to do ulta. So you have to do select exact count to get the exact count. Otherwise, you'll get an approximate count. Abhi the API is something like this. So you can do a select approximate count star from student to actually get the data, and then select count distinct also works, and select approximate count distinct also works. Count wala memory intensive hai, and I'll show you how large the memory is for a trivial 10 million ka data set. So what I've done is I've created a 10 million ka data set which has ID, name, and age. And I'm trying to figure out count distinct in name and age, which are like 10 million में 249k pairs बन रहे थे. So if you see execution time for the exact count, इसको ignore करते हैं because hashing the data requires time. So अगर इसमें 8.5 seconds लग रहे हैं तो इसमें 19 seconds लग रहे हैं. Okay. The actual execution is instantaneous, but this is just hashing ka time. Hash takes this much amount of time. But if you see start memory हुआ था exact count का 25 MB, which is the node का memory, and then there was no exact count calculate किया तो it was 1492 MB. So entirely everything has to be in memory to actually get the exact count. And I'm using JavaScript के objects directly. So it's just a dot length for me. JavaScript का array use करता हूँ तो it's like a dot length for me. So it's already calculated. So there is no time that you require, but this is the amount of memory that is required, 1492. और उसके बाद the test case is in such a way कि पहले exact count निकालता है, फिर उसी test case में it calculates the approximate count, which reduces the memory to 0 approximately. तो ये 21 MB पे दोबारा आ गया, which is the default node की memory. So 25 पे था और 21 पे आ गया when it was doing the approximate count. So like 0 memory, KBs में memory use होती है even for a trillion data set. So for me it was just 10 million. So it should have probably taken only 4 bytes. That's all that it would have taken. But yeah, all of these APIs have landed into StylusDB SQL. There is also a tutorial that Yash has gracefully contributed. So what you guys can do is you guys can just go ahead and see all of the test cases. TDD based hai. You can just go ahead and add the test cases first and try to make it work for your own databases. Okay. And this PR will land. The tutorial ka PR will land by end of day today. Yes, is that the right timeline?
Yes, sir.
Sorry, are there?
Yes. It's the right timeline. Just fixing the tests and it should be done.
Cool. So basically, all you have to do is make these 4 APIs work. Okay. And given that this is our own database, so this dialect is not allowed for most databases, but क्योंकि घर की खेती है, तो we have added distinct with an array of columns as well, just for fun sake. ठीक है. I think I'm done. Any questions? I can show you the implementation as well. Let me just go ahead and do that. But yeah, before moving forward, any questions?
Yeah, do they have explained the logic for using a harmonic mean instead of a weighted mean or a
paper mein hai. So you can go ahead and read the paper. And basically, it's more. So it's not an exact science. ऐसा नहीं है कि मैथ से तुम derive कर सकते हो कि harmonic mean ही use करना चाहिए. It's more they tried out harmonic mean and they figured out that this is doing better, much better than like simple means, at least for this algorithm.
Got it. So it was more like trial and error based on.
So it's some heuristics that based on which they've tried to figure out क्या होना चाहिए rather than exact science. अगर exact science होता तो किसी ने पहले ही निकाल लिया होता. But
Makes sense.
Cool. I'll show you the implementation. In the database itself, what I've done is I've added npm generate. So what you guys can do is npm generate से figure out, create like a large file. Large file में 10 million का data set add हो जाता है, which is like 300 MBs of data set. You can actually go ahead and do much more than that. यहाँ पे 1 billion कर लो अगर तुम्हारे पास enough memory है. I've tried to keep this memory efficient, but it tries to insert data at every 500 K. But yeah, this is the entire implementation. एक large CSV generate होती है, and then there are 3 tests that we are doing. So यहाँ पे we do a large file count star, जिसमें select count star for from student large कर रहे हैं हम, and then we are doing select approximate count star from student large. So what we have done is we run the first query, get the exact data, exact result count star से आ जाता है, and then we use count star plus minus 5% to actually get greater than less than. So it's extremely simple in terms of verifying कि 5% के error rate में आ रहा है कि नहीं आ रहा. Actually, this is wrong. 2% में नहीं आता है. Generally, 5% में ही आता है based on the algorithm that we have right now. Redis has a beautiful algorithm. They have an upper limit of 0.81%. They've tested this around with the cardinality of which to 18, 19 digits of data. So very large data set, but very good cardinality for some reason. I don't know how they've done it. I'll have to figure that out as well. But yeah, for me right now, this test is passing every single time. I can show you that as well. All I have to do is just save. Okay. यहाँ पे रन कर लेते हैं npm run test. Right. So this is the only test that takes time क्योंकि वो memory में large file load करता है, and that's the only thing that takes time. So next session is going to be extremely critical for us because we'll be implementing sort of like a memory. Right now, it's a stateless database. It takes your CSV into memory and then kicks it out of the memory as soon as the query is done. So for every query, it is taking in the page and then removing it. So we want to do that. So as you can see, start memory, end memory, exactly same. And there is practically no memory that is getting utilized. But yeah, what we are planning to do is in the next session, we are going to implement caching mechanism for the entire database based on कैसी queries आ रही हैं, probabilistic query basis पे कौन सी table memory में रहनी चाहिए. That's something that we'll implement. But yeah, cool stuff coming forward. I haven't updated the Prisma ka integration that I did. That is still not having approximate and ye wale counts. So I'm looking for contributors. If there is anyone, please raise your hand. Would love to have this up to date as well. I don't think this can land in the same PR, but yeah, I would want some contribution here as well. Prisma ka adapter, if anyone can update. Utkarsh, are you raising your hand?
No, sir, I am not.
Naini, why are you not raising your hand?
Sir,
that's what I'm trying to figure out.
I am not comfortable with Prisma actually.
Achha, so. Got it. But how many tutorials are you there? I mean, how many have you done?
I am on the 15 tutorials, sir.
Okay.
Like.
Got it. I think that's good. I think do 5 more and then do this one as well. I think this is very interesting because you'll see a lot of improvement here, as you can see.
Yes, sir.
And we have the Bitcoin founder as well. Hi, sir. Great. I think he wants to remain anonymous, so we'll not push. Okay, but basically, it is still 100% code coverage. So any feature that you would want to add would be good if you can add those. Also, there are like 50 more to-dos. So if anyone wants to take those up, more power to you. All of these are relevant to building the database in a much more resilient way. So let me know if you have thoughts around any of these. Would be more than happy to discuss and get these added into the database. Okay. Right. Cool. I'll stop sharing. I think this is it from my end. Anything that anyone wants to ask?
How are we storing the data on disk?
Right now, it's CSV file.
Okay.
So it's a CSV-based database because we started with something. We wanted to start with something crude. So इसलिए CSV है. So as you can see, these 3 files are there like this only, and even the joins, as you can see, are based on. So it just tries to figure out joins based on student_ID, that kind of thing. So student file ka naam hai, and then _ID is the field ka naam, and that's how it will join right now. So it's a very basic implementation, but we want to improve that further. Would you want to contribute, Anshul, on this front? Like having a proper backend for pages and everything? Because I'm planning to do this in the next coming weeks. So उसमें caching भी होगा and then memory layers भी होंगे. So what I'll do is on the disk you'll have either CSV or like my own custom implementation of a page, and then page के बाद doing back and forth in terms of how to get tables and so.
Interesting idea.
करना है तो बताओ. I would love to collaborate.
Hmm.
We can jointly
Yeah.
give the next session as well.
Can do that.
Can do that. Okay. Cool. Also, I'm looking for contributors because right now this has become a mess. Query parser or nahi le sakta regex based parsing. We need a lexer and a parser. Now, based on the kind of queries that we have, I think this is it. The regex has run its course. We need something much more mature. AST based parsing hogi. So that's another ticket that that is needed. Okay. I think I'm done. If everyone else is done, we can drop. Satoshi, are you planning to do the tutorials until 21 sometime in the future? You can type as well. Oh, sooner or later. So, right. Okay. Both. I want to do sooner and later. Please send me 1 Bitcoin, sir. So these sessions are not free. 1 Bitcoin is the price. I'll send you my wallet as well. नहीं यार INR में convert नहीं करते बहुत ज़्यादा हो जाएगा इतनी मैथ्स ही नहीं आती है मेरे को anyway cool thanks everyone Anshul, do you want to connect on how we want to proceed on this ताकि next week or next or whenever that
Yeah.
हाँ
Yeah.
हाँ मैं एक अलग लिंक देता हूँ and then we can connect there ठीक है Yes if you want to
I want to be part of that call as well.
हाँ ठीक है cool. I'm sharing the link here.
Maybe I'll just stop the recording and we can continue here.
If everyone is dropping, then we can continue it. You can stop the recording.